Good morning, class. Today's video demonstration will demonstrate rotational inertia. Rotational inertia depends upon the mass of the object and the relative concentration of the mass to the axis of rotation. So when you take an object and roll it down an incline, you can see that the friction between the object and the incline makes it roll, so a frictional torque is going to make it roll under the influence of gravity with the component of gravity along the incline. So when you look at three objects, we have a cylinder, a sphere, and a hoop. For the cylinder, the formula is 1/2 times the mass times the square of its radius. For a sphere, it is 2/5 times its mass times the square of its radius. And finally, for a hoop, it is just simply mass times the square of the radius. We are now going to do a race and see which one will win the race. So we will place the hoop, the cylinder, and the sphere, and then we will release them. You can see the hoop made it last to the bottom of the incline, the sphere made it first, and the cylinder was in between in the race. Why is that true? Well, the sphere has the most concentration of its mass relative to its axis of rotation. Because of that, the relative resistance will be the least, and it will roll the fastest down the incline. For the cylinder, it is in between. It has more mass away from the axis of rotation compared to the sphere. And finally, for the hoop, you can see that the mass is concentrated more on the edge, so it is going to resist the rolling motion more. So that's why it loses the race. So it depends on the relative concentration of the mass with respect to the axis of rotation.